In this video, I introduce backpropagation for training deep artificial neural networks. Neurons in input layer are used to sample input data that is used as input to artificial neural network. The first layer conducts a summation over all input data and then nonlinear transform to generate his output. Similarly, the information propagates from one hidden layer to next hidden layer until reaching the output layer, as shown here. There's an input layer, there's hidden layers, and this output layer. A loss function is defined on the output layer, which is used to compare the prediction with the ground truth. Artificial neural network is trained to make the difference between prediction and the ground truth smaller than the predefined criteria. Namely, the network can classify our input data into a correct class. Forward propagation means that the input data experiences from the input layer to the output layer. The model parameters W of a network are randomly initialized. The task of training a neural network is to iteratively update the model parameters W using training dataset. The goal is to reach a convergence distribution of the model parameters, and the prediction y hat is close to the ground truth y. The training procedure is to use the difference between the prediction and the ground truth in each time step to iteratively adjust the model parameters. This training procedure is referred to as backpropagation. Namely, the prediction error propagates in backward direction. It's from output to input layer. Suppose that y is a ground truth, y hat is a prediction. The loss function error is defined as here. If a sigmoid function sigma is used as an activation function using this derivative formulation, we can calculate derivative of loss function with respect to model parameter wi in this procedure. We explain this procedure here graphically. After we get this delta wi, we can use gradient descent method to update the model parameters wi. A deep artificial neural network consists of multiple hidden layers, which map input to output step by step. The hidden states in the hidden layer have no explicit meaning. The trained deep artificial neural network model can be used to predict the output of the unseen input data during training in the forward direction. For example, this input layer, this first hidden layer, this second hidden layer, and this output layer. In the forward propagation, the model predicts output of input xi, this output. This is the step-by-step procedure, and we can express this procedure in the implicit function. Backpropagation is used to find the relationship between model parameters and prediction error by backward tracking to determine how to change the model parameters. Gradient descent method is used to update the model parameters W. First, start from a loss function. We step by step calculate the derivative of a loss function with respect to each model parameters here, here, and here. This is a procedure. Start from a loss function. Step by step, we'll calculate the derivative of loss function with respect to model parameters W, ij1. Here we use the implicit function to explain how can we calculate the derivative of loss function with respect to model parameter W, ij1. Here, step by step. For more details, please check with these references. Thank you. Bye.